Welcome to machine learning. Myself, Raghavendra. Here I would like to give a quick insights about the machine learning. So basically, the machine learning comes into supervised practice and unsupervised practice. So in supervised practice, so what we are doing, we want to train my machine, whatever the data, I want to train my machine with the input along with the output labels. And coming to unsupervised learning, I would like to train data with my input data. Right. Here, I would like to explore a sample machine learning life cycle. So if we come up with your machine learning life cycle, so what the things we are doing in the basic machine learning life cycle? We want to get the data. So once we are getting the data, then we want to pre-process the data. If any cleaning or any transformation operation is required, we go with pre-processing and transformation operations. Next, we want to go with split our data, like we want to select input features and we want to select output features. Then we want to split my data, train data, and test data. Then I want to select my algorithm. I want to go with any classification algorithm and regression algorithm. Then you go with evaluation metrics and I go with sample predictions, right? Sample prediction. Now I want to come up with here simple machine learning Knearest Neighbor algorithm. I want to classify a given iris flower data. I want to classify iris flower data, whether it is a setosa or whether it is a versicolor or whether it is a virginica. All right. I want to classify the particular data set. So what I am doing here, I want to upload my data first. This is my Google Collaboratory. I want to upload my data. My data is available in downloads. So iris flower data. And I want to get import library, coming to import pandas as PD. And I want to get my data here, pd.read_csv, where my data is available, the current path. My data is available here. I want to copy path here and I want to keep my data here. So what I am doing, I want to keep my data here, right? So right now this contains my data. If you want to explore display top head rows, I go with head rows. You are able to see top head rows. Now what I am doing, I want to build a simple classification algorithm, nearest neighbor algorithm. Here I want to separate my input features. These sepal length, sepal width, petal length, petal width, all this comes into input features. So here I want to get all these input features here. I want to collect all my input features here. Let's put sepal length, sepal width, and output feature will be, the target will be species. That's why first I want to explore what are the columns right now available in my data. So my data contains the columns. Okay, now I want to separate all input features, the sepal length, sepal width, petal width as X. The X contains all input features. This will contain all my input features, right? And I want to separate the respective Y it contains respective target data. The target, it could be a species. The target, it could be a species. So what we are doing, we try to separate the respective input features and we want to separate the respective output features here. Okay, X and Y, right? So then we want to display those input features and output features. Here X contains all input features, right? So now I want to come up with my algorithm. My algorithm is available from a scale n. So I want to implement K-nearest neighbor algorithm from a scalar and neighbors. Here I would like to implement K-nearest neighbor algorithm. So neighbors, you want to import K-nearest neighbors classifier. So I want to create an object to this K-nearest neighbor classifier, right? K-nearest neighbor classifier. And I want to split my data into training data, test data. That will be available from sklearn, the pre-processing library. So in the pre-processing, we have a sklearn model selection, and we had model selection. sklearn model selection. we want to import train text split. We want to import train text split, and I want to split my data x train, comma, x test, comma, y train, comma, y test, x train, comma, x test, y train, comma, y test, right? Here I want to split my data. So my data is going to be splitted by using train test function, by using train test split function. So here x comma y. So here the split ratio. So here we required a text size. The text size will be, for example, the text size will be so from 30%, and random state. I go with some random state, random shuffle 10 or 42. So what I'm doing here, we try to split my data. Now I want to try my algorithm knn.fit. This is a quick insight how the machine learning is working. So here we providing training data. First I want to train my algorithm with the training data. Rest. Then we go with sample prediction. Okay, here we go with the number of neighbors. So here the neighbors here required, you can specify the number of neighbors. For example, here you go with number of neighbors will be 3. So here you go with number of neighbors will be . And you go with sample prediction. Here we go with knn.predict. And here we go with any sample measurement. So here you go with any sepal length and any petal width, and any you can go with the respect to sepal length, sepal width, petal length, and petal width. See, okay, this algorithm is going to be predict sample outcome results. This algorithm is going to be predict sample outcome results. Here we go with the respected values, sepal length, sepal width, and petal length, petal width. So then this algorithm is going to be predict. So based on input fetch, it is color. This is how our basic machine learning life cycle is working. Predictions are working. If you want accuracy, that will we can go with the Y prediction against Y test. That will be available from sklearn dot metrics. So from sklearn dot metrics, we go with import accuracy score. We import sklearn metrics. We go with import accuracy score, and we want to compute accuracy score. How this accuracy score computed? First we go with Y prediction knn dot predict X text result. We are getting Y test. The original will be available Y test. Then we calculate the accuracy score, and we want to display the accuracy score. That means the accuracy score we are going to be compute accuracy score. That will be against Y prediction against Y test, Y prediction against Y test. So then if you want to represent the same accuracy score, any particular percentage value, you can convert. So this one, okay, this is how quick insights how machine learning will be developed. So thank you all.